Hello everyone, it's been a while since I made a video for KLS. This video's main purpose is to provide an introduction and a quick how-to for the current KLS owners that want to test the plugin before its release in Fab. These are the people that have access to the GitHub. So this video is not documentation and should not be treated as such. Proper documentation will be available in the next 2 weeks before the release. That being said, let's not waste much time and get right into it. So, the main changes of this version is the use of motion matching, remove the usage of linked animation layers, and big masking improvement that uses the copy motion, which was mentioned by Epic Games in their talk about motion matching in Fortnite. So, first things first, let's test using the game animation sample animations. So all I did was migrate it. I migrated this UEFN folder, right click and migrate from the game animation sample to this empty project. So let's start. I'm going to go here, create a new folder, KLS-V4 video. Go to folder, UEFN. Okay, so first things is the animation blueprint, the UEFN skeleton with KLS, the base motion matching. Created APP UEFN. Then we're going to create our data asset. KLS motion matching data. And we'll name it DA UEFN. Okay, so before we fill this, let's find the skeleton, open it, click on this animation. Here it opens a montage. I'll just open the first animation, and let's remove the modifier. This add KLS skeletal data modifier, right click, apply, which will do stuff to the skeleton, not to the animation itself. Go to your skeleton and hit save it. Now we're done with that. Let's get right into setting it up. So we go here, UEFN, let's open this and let's take a look. First of all, let's put our schemas. If everything says closed, let's start with opening the schemas, setting schemas, default. We'll use these schemas have the skeleton that is required, so we'll use the ones from UEFN. Stop, jump, and the normalization set will use the dense all. So we'll test with the dense animation sets here. The base pose is the idle. So let's take a look at the idle animations. Idle loop, and the databases. So idle, and idle, turn in place, and turn in place. So KLS has turn in place split into right and left. So let's open this, duplicate it, we'll name it left. Open the right one and remove all the left from them. There you go. Save it. Now go to the left one and let's remove all of the ones that are from the right. Right, hit save. Go back here. Turn in place left. Landing. Light. Heavy. You can use a land additive, but it's not necessary if you do have the databases. Go to the walk. Can use lean additive as well. I won't be showing that right now because it's not relevant for just the purpose of showing the result and testing. So walk start. Tense. Stand walk starts. Walk loop. Stand walk loop. Stop. Pivot. Walk. Spin. Aim for the landing. Light. I will not speed up this part of the video so you have an idea on the actual time it takes. So run start. Run loop. Stop. Run pivot. And run spin. Run land light. Land heavy. On with the run gate. Let's go to the sprint. Sprint start. Sprint loop. Sprint stop. Sprint pivot. And sprint spin does not exist, so we'll use run spin. And land. Land. Okay. We'll not set up the crash stand right now, but we'll need the jump. So jumps, but we don't have jump loop, so let's duplicate this jumps one. Name it jumps loops. You can have multiple jumps, multiple loops, but in this situation we have only one loop, this neutral jump full loop. Go and find it and remove it from the. So here in the loops, we only need to leave that. So let's remove everything else. And for the actual jumps, well, let's remove the loop from there. Not necessary to be there. And that is everything. Let's put it. Jumps loops. Okay. Now this is for the game animation sample. You only need to set up the tags. Make sure you don't set up parameters, you don't set up the animation curves or notify states, or for everything exists already in it. It could cause issues if you do that. So make sure that you add the database tags, and that's it for this set. So you click add database tags. Any ones that don't have the tags will get added. When you click hit save, everything should be good. Hit save all. And let's go to our animation blueprint and put this UEFN in it. There you go. And now let's test it with our character. So let's go to our character, open it. So the character class itself needs just two things. First, to change the CMC to use the KLS character movement, and to add the component KLS character anim. So this is for mover. Disclaimer, mover is not 100% done yet because there's still changes that are required in the editor for it to work for simulated proxies, and small little changes that are required for me to add and show in the documentation how you can make the rotation be affected by the animations, just like it happens for the CMC. So the KLS CMC takes care of that, so use the KLS character anim with it. Let's make sure that we have our rotations set up correctly. So we have used to control design rotation. This doesn't need anything special. Let's test and see if everything works by going to the mesh, setting it to the UFN, and setting the animation blueprint to hours. And let's hit play. Okay, it looks good. Let's try it to see how it looks with rotations. Orient rotation to movement. Okay, so that was how quickly it was to set it up for the game animation sample animations. You can use the dense, you can use the sparse. Just keep in mind that KLS does not search all of the databases all at once. Matter of fact, it doesn't search most of the time. So it's a hybrid implementation between the game animation sample normal motion matching and the state machine setup. You can take a look at the animation blueprint of the plugin to have a better idea. But to keep this video short, this is just a quick show of how to use. So since we've done it like that, let's quickly try to do it with some other animations and we set them up from the beginning. So for this purpose, I'm going to use the Kallari animation set, which I already have used the modifier from KLS to add the root motion from the curves, from the distance curve that exists in these animations. Obviously, I'm not going to include how I did that or how to use that modifier right now, but it will be mentioned in the documentation. So let's create for her an animation blueprint as well. Kallari, KLS, ABB, Kallari. Why? This location. What? Seems like a bug. There is no APP Kallari here, this location, but yeah. Let's add our data asset. EA Kallari again. Okay. So we have these two. So let's go set up their animations, their data asset, the databases for motion matching. Paragon Kallari, characters, heroes, Kallari, animations. Let's go here and make a new folder, databases, and let's add one. So animation, motion matching, posters database. Before we do the database, sorry, we need to add the schemas. So let's go here, create a new folder called schemas, and let's go to KLS content, and we have schemas here. So let's just select them all, go back to Kallari schemas and copy it there. And now we can rename them from KLS to Kallari. So go inside and change the skeleton to use the Kallari one. If your skeleton has different naming conventions, then you will need to go to inside of the, not trajectory channel, but the group channel. You need to go to the position and make sure that you have these left foot, right foot set up correctly, the correct bones for the feet and the pelvis in the last one. So most of the time you'll only change the skeleton. Okay, save them all. And now let's just go and create some databases. Animation, motion matching, post search database. We'll just use the Kallari default schema and we'll just name him KL idle. Post search database, PSD, KL idle, and just copy. After the idle, we have turn. Let's just turn in place right. And in place left. Start. Stops. Oh, oops. Pivots. Spins. Jumps. And jump loop. Okay, so let's fill them up. Let's open all of them. First of all, let's close these from the UEFN. And let's open all of these and fill them up. Okay. I already split most of the animations here, but let's go for the idle. First of all, this is the idle. Let's put it here. Hit save, close the idle. Next is a jump. I already made a jump anim. Just a little disclaimer. Currently, the jump anim needs to be, because they are different. So KLS would prefer if you have the full jump animation, and we have this. So this, at the first frame, we have a notify for override base coast bias, which has a value of negative 0.2. Or if you can put it higher, you can leave it at negative. Actually, negative 0.2 is the best value you can choose here. And this will make the animation most likely start from here. This is the continuing bias, so if it starts from here, it keeps going, and this continuous bias is at -1. And the block transition, so the animation does not transition in the very last bit. It would transition here when it's about to land. Transition in this section where the velocity is going down, but not at the very last frames. So this is what you would need to do for other animations if you have other animations. Again, base cost, override, and block transition. This is to make sure that the animation plays exactly as you like it to. That's the jump loop. It's called ball loop, I believe. And all of these animations have root motion in them that are already done. So the actual loop animations, let's go inside of locomotion and jog backward, jog forward, jog left, and jog right. We'll only do the jogging animations right now because that's mostly what they have. Pivots. Not gonna use the sprint ones. Spins. Starts. Obviously, you can make a database that has like a jog left stop and right stop, but use the sprint forward and backward like there are here, and put that for the sprint database. But for the purpose of making this video as short as possible, I'm just going to set up the jogging and use it for all of them. So stops, turn in place left, so left, and turn in place right. And now let's go to the databases and set them up. Data asset. So the schemas are Kallari ones, Kallari default, Kallari stop, Kallari jump. We did not create a normalization set, so let's go and make one. Animation, motion matching, post search normalization set, Kallari. Just add it here. Nothing you need to do for it. Let's take that idle pose. This is mostly used for masking, but it's best to fill it. And KL idle, KL turn right, KL turn left. For the landing, we don't have databases, so let's use an additive. It's recovery. Let's jump recovery additive. Put it here. Then we'll fill the walk, run, jog, and run with the same databases. So KL starts, KL loops, KL stops, pivots, KL. As you can see, these animation set from Paragon does not have rotating animations except the spin ones. And for the landing, we'll just Copy. Paste. And now let's copy the entire gate and put it for run and for sprint. For jump, KL jumps, KL jumps loop. Let's hit save. Since we have made these right now, and the animations were not done for motion matching or set up before, so let's set up the animations, curves, and notifies. Once that is done, let's set up all the databases params, and then hit save. Go here, hit save all, and now let's test it out. Let's go to our character, to our mesh, change this to Kallari, and this will be Kallari motion matching. But we need to set up the data asset inside of the Kallari motion matching. So Kallari motion matching. Okay, let's see. Seems like I crashed. The bug with post search, but it doesn't. It happens the first time when you try to use it. Use a database. Definitely not a crash from KLS, so I couldn't fix it even if I wanted to. Let's put the speed to be more in line with. So this uses KLS replicated speed, so this is where the speed is controlled from. Let's just do 350 to be more in line with how the animations are. So as you can see, it works very well. There is no problems. The setup did not take a long time for setting up from scratch. The jumps work well. Everything was good. So let's make sure that our rotation rate is high enough, because KLS does use its own rotation from animations and its own rotations, but that clamps it to the maximum possible rotation rate. Let's put this to use control rotation, and turn in place works well as well. Since we talked about turn in place, we did add turn in place for when you are orient to rotation to movement. You can see here there's no foot sliding. Everything works really well. Let me show you the rotation with orient rotation to movement, because many people asked for it before. As you can see, it works very well. So, thank you guys for watching, and the next video will be about setting up masking quickly, and I'll see you on the next one. Goodbye.